In this lesson, we're going to work on solving and graphing inequalities that require multiple steps to solve. So in problem number 1, we need to find the value of what x is less than all by itself. So to do that, I want to get this 10 away from there. So I'm going to add 10 to both sides. This is a standard technique just like in solving equations. So now I have 3x is less than 12. 10 plus 2 is 12. The 10 goes away. That's the whole reason I added 10, was to make the 10 go away. It's minus 10 plus 10 makes 0. And then I have to divide both sides by 3 to get the x alone. So now 3 divided by 3 is 1x. And x is less than 12 divided by 3, which is 4. And so now I can graph that solution. Open circle because it's less than above the 4, and the arrow goes to the left because it's values that are less than or lower than 4. And so I had to do two things. I had to come up with this solution to the inequality for x, and then graph that solution on the number line, just showing that the values below 4, less than 4, are values that satisfy this inequality. And you could even check, if you weren't sure, you could say, well, just pick any value below 4, like 0. 3 times 0 is 0. Minus 10 would be negative 10 is less than 2, and that's true. So all the values to the left of the 4 would make this inequality work if we were to use them in it to solve it. So let's do another one. A couple of examples here so we can get started on this. So I'm going to subtract 9 from both sides. And some people will ask me when I do this, well, how do you decide what to do first? I'm always doing the thing furthest away from the x and then working my way toward it. So the 9 is not attached to the x directly like the 5 is, so I'm going to start with the 9 and try to get rid of that first if I can. And the way I do that is by adding the opposite to it. Opposite of plus 9 is minus 9. When you put those two together, they make a 0. And 0 I don't need to worry about. I need to keep track of that 5x that's still there. And it says it's greater than or equal to 24 minus 9, which will be 15. And now I have 5 times x is greater than or equal to 15. And so I'm going to divide both sides by 5 so that I can get the x alone. And then that means now 1x is greater than or equal to 15 divided by 5, which is 3. And so the solution to this inequality is x is greater than or equal to 3. So it's a solid dot. Greater than or equal to 3. And that's how you have the solution and the graph showing the values of x that are true for this inequality. And again, I could pick a number greater than 3, like 5. 5 times 5 is 25, plus 9 is 34, and that's definitely greater than 24, so it works. So those are one of the ways to check and see if you're getting the solutions correct. So let's do a couple more examples, one more practice. And remember, you can always freeze these and go back if there's something I do that's too quick or it doesn't make quite sense unless you see it again. So try that. Now the 2 on the bottom here, divided this whole part divided by 2, it's the furthest part away from the x, and so to get rid of it or to make it go away, I'm going to multiply both sides by 2, because if I take 2 divided by 2, that makes 1, and that makes the 2 go away. And the only thing left there then is the x minus 4. And it says that's greater than 3 times 2, which is 6. And then if I add 4 to both sides, then the x is still there. A negative 4 and a positive 4 makes 0, which is the whole reason I added 4, to make that 4 go away. And the greater than symbol stays, and 6 plus 4 is 10. And so my solution is x is greater than 10. X is greater than 10. And so I could check that. I could pick something greater than 10, like 20. 20 minus 4 is 16. 16 divided by 2 is 8. 8 is definitely greater than 3, so it works. You can pick values greater than 10, and any of those values will make this inequality work. So let's do one more example. So this minus 9 can be taken away by adding 9 to it to make 0. So the 8x comes down, and the symbol comes down, and 15 plus 9 is 24. Now if 8x is less than or equal to 24, so divide both sides by 8 to get the 8 away from the x. That makes 1x less than or equal to 24 divided by 8, which is 3. And so my symbol, solid dot, filled in. That's the equal to 3, and then x is less than or equal to 3. So everything to the left of the 3 would be true for this inequality. And again, I could check. I could pick a value for x that's less than or equal to 3. Even if I chose the 3, that should give me a 15 for an answer. 8 times 3 is 24, minus 9 is 15. So in some ways it's better to choose something further away, like 0. 8 times 0 is 0, and then minus 9 is negative 9, and that's definitely less than 15. So it looks like I've got my inequality correct, and I have the dot, solid dot, and the arrow to the left that represents it on a graph. And that's how you solve and graph inequalities with multiple steps. These are really 2-step. It took me 2 steps to get to this before I could graph it.